Hi, Algebra class. Welcome to another edition of Mr. Chow Time. This time we're looking at ratios and proportions. So, a ratio, what is that? Well, if you remember rational numbers from last year, a rational number was a number that can be written as a over b, where b does not equal 0. A ratio is very similar. It's a comparison of two numbers, just as a rational number could be. So, x to y, two different numbers, x to y, x over y. A proportion is an equation or a comparison of two ratios that are equal to each other. So if a over b was equal to x over y, then this would be a proportional relationship, and the equation is called a proportion. So let's determine if the two fractions in this equation are proportional or equivalent ratios. This is just another word for that type of relationship. So how do we get from 2 to 16? Well, we multiply by 8. And if we multiply 3 by 8 also, then we would get 16 over 24. And yes, this is proportional. And just so we are all clear on this, if we multiply both the top and the bottom by the same number, then the number remains the same, right? So for example, 1 over 1, if we multiply this by 2 over 2, then we get 2 over 2. And 2 over 2 should equal 1 over 1, because if we reduce this, then that is 1, right? And the reason that this works is if you multiply any number by a number over itself, any number that's over itself is the equivalent of 1. So if you're multiplying by a number over itself, then you're multiplying by its identity, right? You're multiplying by 1. And by definition, that means you're looking at the same number, just written in a different form. So are these fractions equivalent ratios? Well, we can look at how we get from 6 to 2, right? And that means we would divide by 3. And if we divide the bottom by 3, we do not get to 5. So no, this is not proportional or not equivalent ratios. Okay. Let's look at some more vocabulary. When we're looking at a proportion, it can be written as A is to B is proportional to C to D, right? Or it could be A over B is proportional to C over D, right? Either of these are fine. The second and third term, this is the second, this is the third, this is the second, this is the third. These are called the means. The extremes are the first and the fourth term. The first and the fourth term. These are called the extremes. So the means extremes property of proportion means that the product of the means is equal to the product of the extremes. This is also called the butterfly method. This is what I learned it as. And in this example here, if A over B is equal to C over D, then A times D is equal to C times D. See, it kind of looks like a butterfly, right? So A times D is equal to C times B. This is the means extremes property. It's also called the cross products method, where you cross product, you multiply the ones that are diagonally across from each other. For example, use the butterfly method or the cross products method to determine if the ratio forms a proportion. So here we have 2 and 3.5, and we want to know if that's proportional to 8 and 14. So we could multiply 2 and 14, and that would be 28. And 3.5 and 8. And what is that? I don't know. 28. Yep. So these are proportional. Alrighty. Solving proportions with variables. Sometimes, in fact, often, you know that two ratios are proportional, but there is some value you don't know. And this is really what most real life proportions look like. So you know that x over 10 or x to 10 is proportional to 3 over 5. So that's the same thing as saying, I'm going to not use the equal sign here. Maybe I'll use a arrow. 3 times 10 is 30 is equal to 5x. Divide both sides by 5 and you get 6 equals x. All right, I'd like for you to solve these proportions on your own. All right, welcome back. Here we go. 8 times 25 is 200. R times 40 is 40R. Divide both sides by 40. R equals 5. 5, yeah, all right. Here we have 8 times x plus 4 equals 15. We can distribute the 8 to both of the terms on the inside. That's 8x plus 32 equals 15 minus 32. 8x equals, this is negative 17, right? Divide by 8. X equals negative 17 over 8. Is that right? Did I do something wrong here? No, I don't think I did. Okay. So x equals negative 2 1/8. And there you have it. Here are some more vocabulary words. A rate is a ratio with two different units. So if the top and the bottom units are separate, or if they're different rather, then it is a rate. So a classic rate is speed. For example, kilometers per hour, right? If you're going 45 kilometers for every 1 hour, then you're going a speed, which is a rate. A unit rate is a rate in which the second quantity of the comparison is 1. So this is an example right here, 45 over 1. Here, the second quantity is 1. So this is a unit rate as well as a rate. In the past 2 years, McDonald's has opened 232 stores in Taiwan. If that rate remains constant, how many restaurants will be opened in the next 3 years? Well, in the past 2 years, they've opened 232 restaurants per 2 years, right? And we know that it's proportional. The rate remains the same. So if the rate remains the same, this is a keyword that tells you that the relationship is proportional. How many restaurants open in the next 3 years? How many restaurants? So the number of restaurants is what we want to find. So we'll make that X. So remember, anytime that you are taking a word problem and turning it into an equation, you need to define the variable. And that's a really important practice to get into, because eventually you're going to be talking about relationships with lots of different variables. And if you're just using, if you're using 4 or 5 letters, then when you get to the end of the problem, and let's say you figure you've evaluated for D, well, what is D? I need to be able to know that. Whoever is looking at your math needs to be able to figure out what it is what you're talking about. So always remember to define your variable. So 2x equals 3 times 232. And what is that? Oops. It's a 6. It's a 9. 696. 696 equals 2x. Divide by 2. X equals, what is that? 346. Is that right? Someone correct me if I'm wrong. I believe that's right, though. Oh, I guess I'll just do it. Now you have to watch me do this. Like, oops. yeah, that's right. 4. Oh, and did I do it wrong? I guess I did it wrong, huh? 348. I did. I got it wrong. So wrong. It's actually 348 equals x. Wrong. Okay. Go ahead and do this one on your own. It takes Mr. Chow 47 minutes to run around Lotus Pond twice. Where's my pencil? Here we go. 47 minutes to run around 2 times. At this rate, how many times can he run around the pond in 60 minutes? So x equals number of laps. 120 equals 47x. Oh, I don't want to do this. Get out the old trusty calculator. 120 divided by 47 is equal to 2.55 laps. Okay, actually, I'm going to take a second to talk about this. If you're doing this on a test and you don't have a calculator, you could do this long division wise, but I probably would leave this as a rational number or a mixed fraction. So I would probably have done this like this. I would have said x equals 120 over 47. And then I would have done 2x equals 2. That's 94, right? 94, 120 minus 94, that's a 4, 6, 11, 26, and 26 over 47. That's a 4. 2 and 26 over 47. I would have used this answer. It's more precise, and you should get into the practice of using rational numbers whenever possible, because rational numbers are more precise than this rounded off number. Last vocabulary words: scale. A scale is a rate that is used to make something that's too big or too small to be more usable. A classic example of this is a map. A map represents something that's too big to draw in life size, so we shrink it down to scale. The scale model is the product of using a scale on an actual size object. So again, we can use a map, or we could use like a globe, or those like a skeleton, or one of those model hearts, or a model of an ant, or an atom. And it's just a real life application of using proportions. So I'd like for you to do this one. Welcome back. The Yushan Trail is about 1 1/8 inches long on a map, with a scale of 3 inches equaling 40 miles, right? And the real trail is 1 1/8 inch. So how many miles? What is the actual length? That's an N. And miles of the trail. So that's 9 over 8 times 40. 9 over 8 times 40 equals 3x. We can cross these out. That would be 1. This is a 5. So 9, I'm just going to keep it 9 times 5 actually, equals 3x, because I'm going to divide by 3, And then I can just cross these out and make this a 3. So that's 15 equals x. 15 miles. It's the length of Yushan Trail. You guys should go check it out. It's a pretty cool trail. All right. Have a good one. Goodbye. Didn't